Hey guys, how's it going? Today in this video we'll be talking about iteration. We'll continue with iteration. Last week we went through actually the control structures. Last week we went through if then else. That is one of the control structures that we have. Now today we're going to go to another part of control structure, which is the iteration. Iteration is very handy. Most of the time you use iteration, I would say, in almost all programs that you'll be writing. So yeah, it's going to be very handy, and you are going to enjoy programming after you learn iteration a lot. It practically gives another dimension to the program. So to show what iteration is, I'm gonna today in this video I'm going to make my video with examples, just like I did in my previous video. Include IO stream, right? So using namespace basics. First couple of videos about all this, right? So we have a complete program. Technically doesn't do anything. So the first iteration means, for example, let's say that you want to print out, for example, multiplication table, right? So let me just declare a variable int x, all right? And I'm going to take an input from the user and put it into x that way. But here let me just say that please enter a number. All right, so now I have that. It takes input. Now I want to print out multiplication table for this number, right? So basically what we would do is we would say cout x times cout 1 is going to be equals to, right, we're going to say x times 1 and end line, right? And if you want to print up to 10 multiplication tables, then you're just going to have to do this, right? So this is what you would normally do if you don't know what iteration structure on any programming language is, right? So I would say, all right, now let's try to print it out one just to show you if you don't know what I just typed in. G++, let's compile test, right? So all right, there we go. Run it. Please enter a number, let's say 6, then that is what it shows. All right, that's what we wanted to do. But look, this looks like awful lot of waste of space in programming, right? So to do this in shorthand form, we introduce the concept of iterations. Okay, in this one I'm going to show you one of the iteration structures, one of the most important one. Most programs have that. It's called the for loop, right? So for loop, okay, so we write iteration in for loop. This is the syntax, you just need to remember this. So for, I'm going to have to say initialize a variable, then semicolon, then I'm going to here test condition, all right, and then the third one would be increment or decrement of variable that we initialized. All right, so let me, for the initialization part, let me just say initialize a variable I, okay, and this is a declaration. Now initialize it to 0. All right, remember what I told in earlier videos? I said initialization, I gave you the difference between initialization and declaration. So here, since there is no variable I already defined, I said I is going to be integer, that has to be initialized to 0. Okay, now test condition, I'm going to say that let me initialize it to 1. Test condition, I'm going to say that I is going to be less than or equals to 10, right? And we are going to increment I by 1. Simple enough. All right, now I also told you about compound data types or compound statements. I didn't tell you about compound data types. Don't worry about that right now. We're going to get that very soon. So here we have this. It's a compound statement, all right? But if you just, similarly to other compound statement I told you, if you just need to do one thing, inside these curly braces, then you would not need curly braces at all, but it's a habit, so I'll just write in curly braces. Then what I'm going to do is I'm going to print this right here, and instead of I, where instead of 1 I make it I, and here also I make it I. Alright, now I'll show you what this program is going to do. I told you this would be comments in earlier videos. Alright, I'm just commenting that out. Program, my compiler is going to ignore that completely. So compile it and run it. 7, you see it does exactly the same thing. Now what's going on in this program? Let's see that. Alright, so what this does is it have initialized a new variable I and to 1. Alright, and what this is going to do is it's going to go and do all the statements that is in between these two curly braces, the number of time that we specify using this condition and this condition. These two conditions would determine how many iterations is it going to go. Alright, so what's going to happen is at first it's going to say I is equals to 1. Okay, so when after it sets I to 1, this whole statement right here, this whole statement right here will not have any purpose after that. Okay, just completely ignore about this part. Now what's going to happen, it have initialized I to 1. Now it's going to check here. It's going to say is I less than or equals to 10. Alright, and if this returns true, then it's going to go inside these first curly brace. It's going to do whatever is inside this curly brace if this condition is true. Alright, now it goes through whatever is in here. Then when it reaches this curly brace, then it's going to go to this third part of for loop, which is increment. Alright, so it goes to this part, it increases I by 1, or you can give whatever you want. You can say I is going to be I plus 4 or whatever you want, doesn't matter, but for our purpose I'm just going to increment it by 1. So I increase it by 1. So now after that it's going to go and check for this condition again. After it encounters this, it's going to increment by 1, then check if added incremented I is still less than or equals to 10. Now if it returns true, then it will again go inside this, do all the statements, then it will again come back here, and after coming back here it's going to increment it again, and it will check it again. Unless I is greater than 10, that means it's going to go through here. Alright, and I have printed out I here, so that is what is changing right here. 1, 2, that's the value of I being printed, right? And here I have done x times I. X is what user input, and I is just counting from 1 to 10. Alright, then it's just multiplying that to number, giving out the output right here. Alright, there are other ways to iterate, other ways to count. I'm going to tell about that later on, but just keep that in mind. This part right here, very important. Now let me also tell you something about nested for loop. It's something that some people find very hard to understand, but in fact this is also very good to know. So nested means if there is another for loop inside a for loop, right? So let me initialize another variable to 1, and I'm going to say that that variable of j is going to be less than or equals to 5 this time. Alright, and j plus plus. Okay, so you see now this is nested for loop. Now here let me also do something inside the program. Let me just see out asterisk, and after here let me see out end l. Okay, now let me tell you what's going on in this program. What is going on is, okay, first it initializes I to 1 and it forgets about this part in for loop. Then it's going to check if I is less than given condition, right? If given condition meets, so in this case it's 1 less than or equals to 10. It says yes, then it goes inside and does whatever is right here. All right, then it goes to this part. Now here's another for loop, and it's going to say j is equals to 1, and it also forgets about this part and then goes here, right? So after it is here, it's going to say, it's going to check if j is less than or equals to 5. In this case j is equals to 1, so it is obviously less than 5, right? So it goes here, prints out the asterisk on the screen, right? So right now things to remember, I j, I'm just going to write down the values. So we had I equals to 1 and j equals to 1, right? So then it's going to print out an asterisk. Then when it goes here, it increments j by 1, right? So after it gets here, it's going to increment the value of j, not for the I. Very important to know. All right, so it goes here, increments j by 1. So basically I can say it's 2. I value has not changed because it haven't yet reached this condition, because it haven't completed this part yet. All right, so it goes here. You see it prints out another asterisk just after. Let me also say output, anticipated output right here, and that was first. Now that's what it's going to print. It's going to go here again. Let me just make it a little short. Let me make it 3, and let me make this one 5, right? So just to make it shorter. So then it goes here after printing this, and it increments j by 1. After it increments j by 1, value of j is going to be 3, right? And when it is 3, it is going to check again if j is still less than or equals to 3. It is not less, but it is equals to 3, so this condition satisfies. So it goes in here again, and it's going to print out another asterisk right here. All right, so after it prints that out, then it goes here again, and this time something different happens. What's going to happen is it's going to increment j by 1. Now j's value has become 2. All right, so 4. So after j value becomes 4, it's going to check is j less than or equals to 3. Then it's going to return false, so it will not go inside this line. All right, it will just get to next line after this last curly brace here, and it's going to go to this line. So end line means just that in this screen. All right, and then it's going to go here again. Now it's going to increment the value of I, right? So value of I is 1. It's not going to do anything about j. All right, so value of I was 1. Now value of I becomes 2, right? So after value of I becomes 2, it's going to go here again, and it's going, since okay, this initialization, this part in any loop, that happens when it when the control have gone to this part for the first time. All right, so it goes here. Now it's going to again initialize the value of j. All right, I don't know if I told you about the scope of a variable earlier or not, but I'm just going to tell you a small thing about scoping. Scoping is that I declared a variable right here. That means that this variable j is not going to have any effect outside this part, this curly brace. All right, that is called the scope of j. It's not going to go outside this curly brace. This value of I is not going to come outside this curly brace. So if I try to print here cout I and do that, it's going to give me an error. All right, if you want to use I outside this curly brace, initialize I here and just use that I like that. All right, but for this purpose I'm just going to do that. All right, so if I did that and said cout I, then what this is going to give me is error in the compiler. The compiler is going to say that I is not declared because it could not find I for these curly braces that is also outside these two curly braces. All right, I is not even defined. I is only known inside this small part of the program. Okay, outside this part I is unknown, it's not even declared. All right, that's the scope of a variable. That's also very important. A lot of people have errors regarding that in the program. All right, so we got that one. Now so we were here, value of I is 2, right? So since when it gets out from here, value of j is gone, value j is not even declared, so it's initialized here again. That's why it will not give any duplicate initialization or duplicate declaration error in the compiler, because we are not doing it 2 times, we're just doing it once. The only thing is that we are going to this line again and again. All right, we're not writing this line over and over and over again just inside. If I just have done int j here, then that would have given me double declaration or double declaration of j error or warning in a program. All right, so here now it's now initializes j to 1, right? So j becomes 1, then goes out and prints out asterisk right here, right? Then again j becomes the same thing that we had earlier, like that, and goes again to this line after the value of j has become 4, prints out, goes to next line, then increments value of I. So you can see what it is doing here. So that's what we anticipate as the output, right? So these 5 lines here, it have 5 lines because the outer loop, it has 5 lines. It have 3 asterisks per line, that is because of the inner loop. All right, it's fun to do a lot of programming on these kind of things. It's after this it becomes I have told you one of the very important tool in programming. I have taught you one of the important tool in programming, but after this you are going to have to use a lot of logic for a program to do a lot of things. All right, I'll tell you what I mean in just a minute. So let me just get rid of these. We know what is our anticipated output. I'm just going to see if that's what we get. So there we go, exactly what we thought it would get. All right, I hope you guys understand this. It's very important. So let me just use a simple logic, a different kind of logic here. Now this time, instead of 3, I'm going to make this inner for loop dependent upon the outer for loop. All right, so this becomes quite a bit of task for a lot of people who are just getting into programming, but practice these kind of things. I'll just show you what this program does here. So value of I, value of j, right? Just if you got confused, if you didn't got the output as expected, just keep track of how I'm doing here. It becomes really helpful. So all right, so we go here. It initializes the value of I to 1. All right, so value of I1, no doubt there. Now it goes here again, it initializes the value of j to be 1. All right, so value of j at first is 1. Now it's going to check, is value of j less than or equals to value of I? Then it's going to say it is not less, but it is equals to, so yes, true. All right, so it goes in here, anticipated output, right? So goes here, prints out 1 asterisk right there. All right, now after printing out this 1 asterisk, it can have it will again go here. After it reaches here, it's going to increment value of j by 1. So basically it becomes 2, and it's going to check, is value of j less than or equals to I? No, this time value of I was 1, now value of j is 2, it is greater. So it is not going inside this part. So it exits out, comes here. So after it goes here, it prints out n line, so it goes to the next line, and then it goes right here, increments the value of I. So I becomes 2, and then goes here again, it starts the value of j with 1, right? And then after it gets there, it will print out 1 asterisk, then goes here, increases the value of j becomes 2, checks is j less than I, less than or equals to I, then it's going to return true because it is equal. So it's going to print out another asterisk here, right? And then it goes to next line because next value of j is going to be 3. All right, so after it prints out next line, value of I is increased to 3, and when it becomes 3, it goes here again, 1. When it is 1, it prints out 1 asterisk. When it is 2, which is also less than I, another asterisk. 3, which is equals to I, so another asterisk. But 4 does not satisfy the condition because it is not less than or equals to I, so it goes to next line, right? So you see what it is doing here. So it's going to give me 4 star next time, and then 5 star next time. It's going to have 5 lines because outer loop is counted 5 times, inner loop is counted the number of I times. All right, so you see the pattern here, 1 2 3 4 5, just counted numbers. All right, very simple. Yeah, so we can also, let me just show you that's what this program does. All right, there we go, you see exactly what we anticipated. All right, now next a little bit different. I'm just going to give this, initialize the value of j with that, and we're going to loop until value of j reaches 1. This is just logic. This is something that I cannot make you understand other than just showing what this program is doing. It's all up to you to understand the logic behind this. I'll just try to make it as easy as possible. So if you got lost in this, just make this kind of table that I have here for different for I and j, right? Track the values. It becomes really easy when you do that. So value of I is 1, value of j is initialized to 1, right? And it's going to loop until j is greater than or equals to 1. The reason that I did greater than instead of smaller than this time is because value of j is decreasing, right? So if I would have made this one increasing, this would have satisfied the condition forever, unless this would have gone to infinity. You see why? It does not really goes to infinity, but you're just going to be stuck in long loop. Eventually it gets satisfied because in C++ it loops back after it reaches the maximum value of integer variable. Yeah, but that's not what we intend to do, right? So we decrease here, and we're going to check if it is greater than or equals to 1, right? So now check the condition. J is equals to 1, so it is true. So anticipated output is going to be this time 1 asterisk, right? And this is just, I'm just showing different logic. It might give us same result as the previous example or different, we don't know, but this is something just twisting things further. So we have that, and then next time it's going to be 2, it's going to be 0, right? So it's going to go unless this part becomes 0 right here, unless j becomes 0, that's up to when it's going to go all the time. So then satisfies the condition, goes out right here, prints another line, increases the value of I to 2, then changes the value of j to make it 2 to start with, right? So value of j is 2. It's again counting same number of times, it's just counting from backwards. All right, so since it is 2, to get to 0 it have to have 2 iterations, then when it gets to 3 it have to have 3 iterations. So basically the same output that we had earlier, right? So nothing different here, just a different logic that we are using, right? So you can do a lot of things just using this part. Also let me now this time make this 5, we start with 5, then this one less than or equals to less than or equals to 1, make it go that. It is still is counting towards 5. We're still going to have 5 lines, but just counting it differently. I'm going to make it what we had earlier with the loop and j. We normally use I and j for loop in programming. So 3, right, and make it plus plus like that. So just track the output. I'm just giving you some example because it becomes very hard to understand a lot of time. So j, let's see, 5, right? I starts at 5, j starts at 1, right? So anticipated output seems to be a little bit different this time. Let me make it to I, not to 3. All right, anticipated is going to be, right, so j have to loop until it is less than or equals to I. So I is 5, j starts at 1, so basically it's going to have 5 stars right there. All right, it goes here, decreases I, makes it 4, right? J again starts at 1, so difference between these two is 4. So next time j is going to go 4 times like that. All right, so we can easily see 3 times, 2 times, once. Then since it have 5 lines, or value of I is completed, it's going to get out of the program. All right, simple enough. This is one very aha moment in programming, and it is very helpful to write programs in this way. So let's say that in a program you want to just get out of the program for some reason. All right, so let's say that you don't want to loop anymore. You might have conditions to sometime not go through the loop any further. In that case, you can use something called a break on this thing. So here I can say if I double equals 3, put that in parentheses, right? I can say when I becomes 3, I can say break, right? So what's going to happen, what this is going to do is, even if I said that I should be less than 1 to end out of the loop, because I have said when I becomes 3, whenever I reaches 3, it just is going to get out of the for loop and do whatever else is written here. All right, so it's just going to get out. All right, so it's just breaking out of the for loop. If I would have put this one in here, made it to j, so what it doesn't matter what the condition is, if j reaches 3 at any point, it's just going to break out of the loop. All right, and also I can also do, so that's a break statement. I can also do when I gets to 3, I can say continue. So what this basically does is that it just gets this program to not go through any further part in this particular iteration. All right, so when let me just make it I. So when I becomes 3, whenever I becomes 3, it's going to skip through all this part and just go to next iteration of I. It's just going to skip whatever is after this line. All right, fairly simple enough. Those are continue and break. There's also go to statement, but that's not recommended. So I'm not even going to talk about go to statement because it's also not good to use on a program. There's a lot of risk in using go to. So that's pretty much all for loop concept that you need to get, I think, and it should be simple enough. You can play around with this, you can do a lot of things. I'm going to put a lot of exercises for loop in my website. You can go and check that out. It's almost complete. All right, and it should have a lot of different things that you could try on the program. With this, I'm also just quickly go through another types of iteration in this same video, and we will be done with the control state structures. And all right, I'm going to talk about while loop. It's also same as the for loop, but what we do in a while loop is in while we just give condition inside. So basically I'm just going to check I'm just going to say, I greater than or equals to 1, right? So for this, you can easily guess I have to declare I outside, initialize it, right? So we have I. Let me just get rid of all this from here, right? So while I is that, then loop. All right, do whatever you like right there. So if I run this program, it's going to go to infinite loop. Guess why? Because if I, let's say, just say asterisk, is going to print asterisk in my screen infinite number of time unless I force stop my program, because the value of I has never changed and it's always going to be equals to 1. So there's no way it can get out. All right, this is also loop. All right, it's in while loop you just give a condition. Unless that condition is satisfied, it is going to go in here and do whatever it had to do, whatever we ask it to do inside these curly braces. All right, so in this case you also give the iteration inside these curly braces. So I'm going to say I minus minus like that 5. That means it's going to print asterisk 5 times. And you could also use nested. You can see right there in the same line, because I haven't added end line here, so I can add that and it's going to give me that, right? Pretty simple enough. Nested while loop also has the same concept, so play around with while. Then there's also something called do while. That's a little bit different than while. The only difference that I find between do while and while is that, remember, this is a very simple to understand. Let's say if I do here do, right, one can easily guess this one too. Let's say that I do greater than or equals to 1. What's going to happen is it's going to go inside this part at least once. All right, so that's basically it. It's going to do all this, and in the end only it's going to check if the condition is met. All right, till that time it's always going to loop at least once. Sometimes you might have condition where you have to go through the loop at least once and check for condition. This is very useful during that time. So do while loop, for next, those are the iterations that you need to understand. I'll say, let me see if I have anything else that I need. Also, you could also use exit function. you could use with exit code 0. That means just get out of the program. It will not even go to any other line or anywhere else. If you put this line in your C++ program, it just is going to get out. All right, but to use exit, you might have to use a library file include cstd lib. All right, so that's what you use to use exit in a program. If you want to exit your program at some random point, you can use that. All right, so that's pretty much all the control structures that I can think of. But there's one more thing that I need to talk. It's called a switch statement. Switch is it's called a selective structure. I would say it's pretty similar to how if then else works, but this is how it works generally. So you use switch is a keyword. All right, then you're going to give an expression. All right, then inside here you can see case, right, and a constant. You have to give a constant here to check for. Then you can use a group of statements. You will not need any curly braces or anything. In fact, if you use curly braces, I think it's going to give you error on this thing. Constant 2, right, and to that another group of statements, right, break. I'm going to tell what all these thing is about in just a second. And in the end you just give a default, right, and you can say group of statements just like that, right. So that's how switch works. So so here what you do is, let's say int x again, right, cout, we're going to say please enter a number. All right, and I'm going to c into x like that, and here instead of expression switch x. So now what this is going to do is it's going to take x, it's going to take the value of x, okay, and we use x to test different conditions here. Okay, for example, let's say if x is 30, right, I can say here cout number is 30. All right, and then I can also say cout double number is 60, right. So you see what I'm doing here. So let's say 120, right, and I'm going to say cout double is 120, right. So as you might be able to see, and here I'm going to say I do not understand your number, right. Pretty simple stuff. I'm guessing a lot of people might have already guessed what this is doing here. So what this basically is doing is that user inputs a value, it stores in x. Now it's going to check for that x for different constant values. All right, so let's say if user have input 30, if x contains the value 30, then it's going to do whatever is in these lines right here. All right, so unless it encounters another case. All right, and you might notice there's a break here. There is no break in this one. I have put that intentionally. That's because in what case does is, if you don't put break, it's also going to check for another condition right here. Okay, sometimes you might not want that, so it's always good to do that like that. But if it is this is there is no break here, it will also check for each and every other case unless it encounters a break. All right, after it encounters a break, it just gets out from here. All right, so default means if user has input 30, it's going to go inside this case and do all these things. If it gets into 120, it gets in here, it does all these things. Otherwise it's going to do all these things. All right, so this is basically pretty much similar to if then else that I taught in my last video. So I can just write this one in if then else as if x double equals, is very similar to that. If x double equals 30, right, then I can just say that right here. All right, and else if, right, else if x double equals 120, right, then it's going to do this one line, right, and default is else if no condition satisfies, then do this. All right, that's how switch statement works. Useful sometime, but normally I don't use it very often, but that's how it works, just so that you know. All right, there's just remember there's also switch statement. You can give bunch of numbers here. If you give 120 here and break, it's not going to go to this part, it's just going to go it's just going to do this and get out of here. All right, but if you don't have break, now this time it's going to go print out number is 30, number is 60, double is 120. All right, that's the use of break here. All right, so that's pretty much all of these control structures. You have gone through iteration, switch, for loop, do while, if then else. That's all control structure we have. Starting next video, you'll be getting a little bit more into what we call the object-oriented programming. That's what C++ is most famous for. Object-oriented programming is basically the modern programming that we do. And once you get there, it becomes very, very exciting to program a lot of things. We'll get into classes, class of objects. You'll know a lot of things about. There are also something called friendship, inheritance, polymorphism, advanced thing. We'll get into that once we get to object oriented. But before that, we'll talk about functions in next video, which is also very, very interesting. Once you get to function, it becomes a lot flexible. Your programming is going to become very, very flexible when you get to functions. And it after that we'll get to compound data types, and it's very important. It's about arrays, character sequence, pointers, linked list, that kind of things. Also dynamic memory, that's all I would say intermediate level programming things. And once you get there, and if you have enjoyed the video so far, I can promise you, I can guarantee you that you're going to have a lot of fun doing programming after you learn all those things. All right, so I just want you all to practice all this. I'm going to put up all links in my website. Go to my website, learnfromsujeet.com, SULEARNFROMSUZZETT.com. I'll put the link down in the description, or you can also see that in the screen. And after go there, just make sure you practice whatever I put in there, and you should be practicing a lot to get deep into the programming like this, and it's going to be really helpful in near future if you want to get a lot more into programming and do a lot more other things other than just printing out and taking input. And thank you for watching.